this is Dr. Mears. Today we are going to be learning about arithmetic series. And in arithmetic series, we first need the arithmetic sequence. The first example that we're going to be using is going to be dealing with this sequence right here. 3, 5, 7, 9, so on and so forth. So let's begin. First, the definition and example. Arithmetic series is the sum of the first n terms of an arithmetic sequence. The first 10 terms of an arithmetic sequence are, so here's our example that we just saw before. To calculate the sum of the first 10 terms, please add them up. When we add them up, we get 120. Therefore, the sum of the first 10 terms is 120, our first arithmetic sequence. Now, expanding an arithmetic sequence. In order to find the sum of an arithmetic sequence, we may need to expand it. So here we need to find the sum of this arithmetic sequence, 5, 10, 15. Please notice the middle numbers are missing, so we're going to have to fill them in. That's what I mean by expanding, filling in these missing numbers. And then it stops at 45. Okay, to expand. First, we have to find our common difference. So what do we do to get from one number to the next number? And what we do to get from 5 to 10 is going to be the same exact way that we're going to get from 10 to 15. So I believe here we add 5. We add 5. And then we would keep going and adding 5, making this an arithmetic sequence with a common difference of 5. If you would like to put down plus 5, that's absolutely fine as well. Now that we know our common difference, we can fill in the missing numbers of this sequence. So use your common difference to fill the missing numbers. So we're doing 5, 10, 15, 20, 25, 30, 35, 40, and we stop at 45. And this is why we needed to know our common difference so that we could keep going with that common difference. Plus 5, plus 5, plus 5, so on and so forth. Your turn. Find the sum of the arithmetic sequence, 4, 7, 10, so on and so forth down the line until 25. That's our ending number. So first, let's find the common difference. What are we going to do to get from 4 to 7? From 7 to 10, because they're going to be the same. So, do 4, 5, 6, 7, that's 3. Or you can just simply take your calculator and you can do 7 minus 4. That gives us a common difference of 3. So if you don't know, if counting, you don't want to count, if you just want to simply subtract 7 minus 4, we see that we're going to be increasing by 3 every time. Either way works. So our common difference is 3. If you want to put plus 3, you're more than welcome to. So let's expand this out. We're going to start at 4, and then we're going to keep going, expanding by 3 every time until we hit 25, and then we're going to stop. So how many numbers do I have here? 1, 2, 3, 4, 5, 6, 7, 8. I have 8 numbers. So we're going to be finding the sum of the first 8 numbers. And that's what an arithmetic series is. It's the sum of the first 8 numbers, the first 10 numbers, the first 12, the first 100 numbers. So this takes on the value of n. So our n right here equals 8. That's going to come in handy when we start finding sums for larger and larger amounts of numbers. Okay, so let's find this arithmetic series. Let's find the sum of the first 8 numbers. This is an arithmetic series. Okay, well, in order to do that, we simply add them up. And when we do that, we're going to get 116. So the sum of the first 8 numbers is 116. How about this one? Find the sum of the arithmetic sequence. Now, if you hadn't had a chance to do this previously, why don't you pause right now and try it out? Then you can check the answers. Okay, first let's find the common difference. So in order to get from 1 to the next, 1, 2, well, that's a common difference of plus 1. We are increasing here. So we have a common difference of 1. Expand. almost did plus. We're not finding the sum yet. And then 15. So we went from 1 all the way to 15, adding 1 every time. Plus 1, plus 1, plus 1, all the way down the line. That's a common difference. Let's find the sum. So in order to find the sum, what do? We add up all the numbers. And what are we going to get? We are going to get 120. So the sum of the first, how many numbers do we have here? We've got 15 numbers. Let's write that out. The sum of the first 15 numbers is 120. So notice this number for this example changed. Last example was 8. The previous example was 10. Now we're finding the first 15. I see a trend here. We are going up and adding more numbers. This can get pretty tedious, don't you think? Let's move on. Now this. Find the sum of the arithmetic series 1, 2, 3 all the way to 40. Wow. Wait, what? Do you really want to add up all those terms? Do you think there is a better way than taking the time to add all of these up? Remember, we are becoming mathematical thinkers. We are becoming mathematical leaders. We always ask, is there a better way? Is there another way? Is there a way where I can be more efficient and that will work every time? You know the answer to that. That's why we're here. Yes, there is another way. But before I tell you that way, we need to be investigators. We need to try out some patterns. We need to try to find a formula that would help us. I'm going to actually give you the answer, not a formula, just the answer. I'm going to tell you that the sum of the first 40 terms, first 40 numbers, is 820. So we have 40, 1 to 40 is 40. If we add up 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 all the way to 40, I'm going to get to 820. 820. So I would like you to try a few things to see if you can come up with a formula. You could remember arithmetic sequence formula. It dealt with a common difference. It dealt with the first term. And you can try to manipulate that. So take a second. Try to see if you can find a formula, maybe working with some of these numbers. We also know that the common difference is 1. So investigate. Okay, you're back. But before we see the big reveal, we need to know some symbols first. IB definitely loves their symbols. N is the term number, or the number of terms we need to find the sum for. That's N. U1 is the first term. U sub 1 is the first term. U sub N is the last term. S sub N is the sum of the first N terms. Let's write that down. The sum of the first N terms. So if we had 10 terms, it would be the sum of the first 10. If we had 8 terms, it would be the sum of the first 8. If we had 15 terms, it would be the sum of the first 15. 40 terms, sum of the first 40 terms. This down here, I love this letter. This is the Greek letter sigma. This is sigma. And it's the Greek letter for summation or sum. This just means add it up. This is what it is, add it up. We're going to get to this one later, but I wanted to put it on your slide deck for you so that you would have it. Okay, here we go. Now some math time. So we have our arithmetic sequence 1 to 40. We want to add them up. That would mean we'd have to go 1 plus 2 plus 3 plus 4 plus 5 plus all the way plus 40. Filling all of these numbers in, of course. This means that we have 40 terms. That's a lot of terms to add up. From the 40 terms, we have a common difference of, well, what are we adding every time here? Every time we're adding 1. Okay, common difference of 1. Let's see what our first term is, because I'm going to need that. So our u sub 1, which is our first term, is 1. I'm also going to need my last term. My last term is 40. So my u sub n is 40. That's my last term. I think that's all I need for my formula. Okay. In my formula, what we're going to be starting with is we're going to be starting with s sub n. S sub n represents the sum of all these numbers added up. I want to know, what is the total sum, all added? All right, that's this number. This is going to equal, what we're going to need to do is we're going to need to take the total number of observations, the total number of terms, n. I didn't mean to write the 40 yet. Okay. The total number of terms, n, we're going to have to cut that in half and multiply it by two numbers. The two numbers are going to be u sub 1 and u sub n, the first and the last. And what we're going to do is we're going to add them together. So I'm going to add these together and multiply by the number divided by 2. So here we have s sub n equals, let's try this. N is 40 divided by 2 times u sub 1 is 1, u sub n is 40 plus 40. Now, if these two, yes, they appear the same. These two will not appear the same all the time. This just happened for our example. You will have different n, and you will have a different ending number, but it did work out that these were the same. Okay, let's do some math. So we have s sub n equals 40 divided by 2 is 20, and 40 plus 1 is 41. S sub n equals, and we're going to come out with 820. Now, on the calculator, if you would like to do, let's see, parentheses, 40 divided by 2, and parentheses, keep the fraction together, and then times, parentheses, 1 plus 40, you can do it all in one line. You can take out order of operations. You don't have to use that right here. What you do need to use are parentheses, and you can put it in the calculator, and we get 820. So if you remember to put the parentheses around this, or you can even say, all right, I know what 40 divided by 2 is. You can even do it in a couple steps. Okay, 40 divided by 2 is 20. So you could have even done this, 20 times 1 plus 40. You could have even done it in 2 steps like that. So please, please, if you're having trouble with order of operations, please do not get tripped up with order of operations. Take out that calculator. All right, so here we have we started with visited arithmetic series. We started with a sequence. We started expanding it out and said, whoa, whoa, whoa. There has got to be a better way than doing this than adding up all 40 terms. We wrote down a couple of pieces of information. The total number of numbers here, if we kept going, there would be 40. We have a common difference of 1, which we didn't need because we're actually finding a sum. So we didn't need a common difference. So that was out. We have our first term and we have our last term. And it was just a coincidence that these are the same. These will not be the same all the time. Just happened for this example. Here we have the formula, the total sum. So all of these numbers added up, you're going to get by dividing the total number of terms divided by 2 times, this is multiplication, the first and the last term added up. The first and the last numbers added up. First number Remember, term is number here. Last number. Total amount of numbers. So if you get confused of me using the word term, you can change the word term into numbers. So this is the total amount of numbers. This is the first number. This is the second. This is the last number. First and last. Add them together, multiply, and we got our answer, 820. This has been Arithmetic Sequence slide deck. Please make sure you have the slide deck, you have the answers, and you put them in your folder. Hope this helped. Thank you.